Hey, just making sure you guys can hear me, right? Yes. Okay. Great. So welcome to the second day of CAM. I know the first day was a little bit fast, and so I'm hoping like we're gonna do nesting today, and so nesting doesn't take that much time, and so hopefully we can go back to day one and like sort of redo it a little bit, so you guys can have like a second go at it. Um, yeah. So let's get started. I did make this presentation like right now, so it lacks pictures and like the English might be bad, but other than that, it should have information.
Wait, before you do that, Jonathan, just
Uh-huh.
to like a recap of what we did in the first day, because some of you, I don't know if all of you guys were here, but
Okay. So
yeah,
yes. So first day of camp training, what we did was we basically took, let me find it. We took this backplate here from a gearbox from like a random catathon, and we basically cammed this. And so if you have Inventor Cam installed and it installed correctly, basically you would have a cam tab on top. And what we did was we created a setup. So that's like setting up basically where we're going to cut, how we're going to cut, which direction we're going to cut in, X, Y, and Z. And then you have a templates basically for camming, which have drill, adaptive, like doing pocketing, and then like the final shape basically. And then we also covered like difference between end mill and drill because they look similar. And if you're machining for the first time, you might confuse them, but they're very different. A drill has smooth sides, so it only cuts up and down. An end mill has sharp sides. So when you rotate it and you move it along like a piece of metal, it'll cut a path out. Yeah, and then we just went through step by step how to cam. There's a recording that's uploaded to the website. So in case you want to, I'll actually see the process. You can look at that. But yeah, so that was that day. Going back to today, so we're gonna cover nesting. All right. So basically, when you're machining during the season, you generally don't machine a single piece, right? Like if you have a drivetrain gearbox, you have a back plate, a front plate, and you have two of those because you have two gearboxes on the twirl drivetrain. And then we do two robots, generally a practice bot and a comp bot. So that also multiplies everything by two. So you're gonna have to cut out a bunch of pieces at once, right? And ideally, you could lay the pieces out in a way that you take up the least amount of space, right? Because we don't have infinite supply of aluminum. And so if we could reduce the amount of stuff we waste, that would be great. And the way you reduce waste is like if you put everything close together, as close as you can, but while still being safe, and you do that. But if you were to do that manually, like you go open an assembly and you put like 4 gearbox plates and you try to arrange them in a way that's super space efficient, it would take you a while because you're doing it manually. And then you also have to think about it a lot, like trying to figure out which orientation works. And it's like a lot of trial and error. And so nesting is basically this process that allows us to do that automatically. And we don't have to worry about all that tinkering basically. And so if you install Inventor nesting, it's kind of like CAM where it's an add-on to Inventor. So it won't be like its own application. It's part of Inventor. And yeah, so this is a brief overview of the process when we do nesting, and we'll actually do it. So basically the way the whole nesting software works is it uses what's called a sheet metal flat pattern. And all that 4-word phrase means is it takes your 3D part and it creates like a 2D version of it. And it uses that 2D version to create the whole map for like where everything should go. And the reason why it does that is because 2D is easier to understand than 3D. And it can basically like get surface area and other numbers. And that's how it works basically in the back end. And so that's why before you start nesting, you actually have to go through each part and you have to convert it to sheet metal, and then you create a flat pattern of it. And you also have to make sure the thickness of your material is correct because that's what nesting uses. And then once all your parts are ready, you go create your new nesting file, and then you import all these files. I know some of you guys watched the nesting video that's on the website, so you might already know this, but this is an overview. And then inside nesting, you can do a few things. So you can edit the quantities of each part. So like if you want 2 of those gearbox plates and 3 of another gusset, right? Stuff like that, you can edit that. You can also edit the area you're working with, right? So let's say you're on the Omeo where the size is smaller. You could change it to the dimensions of the Omeo so that everything fits within those dimensions, right? If you're on the Laguna, you can change it to that. If you just found this piece of aluminum that's like, this happened during the season actually, when I was doing the drivetrain gearbox, I found a piece of quarter aluminum that was super long, like 4 foot long, but it was only like 8 inches wide. And so obviously a square pattern of gearbox space wouldn't work there, right? I need something that's long and narrow. And so that's where I changed those dimensions so that I could fit that space. Yeah, and then you can also set how much minimum space should be left between each part. Now, this is really important because remember, an end mill isn't infinitely thin, right? An end mill has thickness to it. So if your end mill is 1/4 inch thick, right, and I'm cutting a piece here, the next 1/4 inches of it are cut by my end mill. And so if I had another piece, another gearbox here, I would actually cut into that gearbox. So you need to make sure that your pieces are spaced enough apart so that your end mill can actually cut them. And so what we use generally is the diameter of your end mill times 2 because you're going to do 2 passes, and you leave 0.005 inches in the middle so that your basically the middle portions don't fly out. And you'll see what that means when we actually do the cam. And yeah, and once you finish nesting, it'll basically create this 2D map of where everything should go, and you can export that through a 3D model, and that 3D model will be where you do your cam. Let's see, there's a chat. Oh, okay. All right, so do you guys have any questions as of now?
By the dimensions, like
Mhm.
giving the stock dimensions, does that mean like you restrict, like if you restrict one, will it like be adaptive in a direction? Is that like, does that make sense?
Yeah. So you're basically restricting like how big it can be. So it'll basically try to adhere to like the dimensions you give it. And if it doesn't work, like there's just not enough space, it'll tell you that it doesn't work. It'll show like some parts in red, but yeah, so it's like you're restricting it. In terms of like, can you only do one dimension? I don't believe you can just say like, I have something that's 8 inches narrow, but I have infinite space. But you can just enter something like 48 inches, right? That's a lot. And so it'll be similar to if you did like infinite space. Yeah.
Okay.
Okay, if you don't have any questions, we can get cracking. All right, so we're back to this plate. Let me check again. I think I didn't save changes last time, so the thickness is off on this thing. Yeah, I don't know. This is my like one of my first catathons, so this is very bad. But we'll change it to 1/4 inch aluminum, and we'll begin from there. Right, so I have my gearbox plate. I haven't cammed this, right? So this is not cam, or I did cam it last time, but I deleted the cam. And so what we're gonna do is we're gonna first step just convert it to sheet metal. So if you're in 3D model mode, on the top right, there's a button for converting to sheet metal, and you just click it, and it does things, and it becomes a sheet metal part. All right. And so here, the first thing is if you click on sheet metal defaults, this is where like some of the properties are. And so if you set your materials correctly, it should already be there. Now, the important thing here is thickness. So it says here it's checkbox use thickness from rule. We want to disable that, and we want to set the thickness to what it actually is, right? So obviously this is a 1/4 inch piece, so it should be 1/4 inch. Yeah, it doesn't like automatically pick up the thickness from your part. So you have to manually set that to whatever it is. If this was like an 1/8 inch part, you would say 0.125 or 16th inch, right? So on and so forth. Hit OK. So that's step 1 done. And then the final thing we do is create a flat pattern on the right here. And it creates this flat pattern. You can see it's flat. And then you can just flat pattern. That's all you need to do, right? And then you can save the file. Yeah, okay. And then, yeah, so basically like you can't save it in a flat pattern mode. It's like sketch. So you can just go outside of flat pattern, go to flat pattern, and where did that button go to go back? I'm confused. There is a button that says like go back to normal mode, but for some reason it's not there. Anyway, you create a flat pattern, you're done here, you save it, and then you close. All right, so actually I'll do another part because we're gonna show multiple files, right? So here's a different gearbox plate that looks to be 1/4 inch. So convert to sheet metal. Oh, contains features that are unsupported. Oh, I think that's the rule fillet. Okay, whatever. All right, we'll do something without fillets, which sucks, but whatever. Sheet metal, use thickness, so 0.25, hit OK, create flat pattern. There's our flat pattern, save it. There it is. Right, so now if you go on new, right, this is where if you have nesting installed properly, if you scroll down, there's now a new option, standard.inest, right? So this is what a nesting file is. So you hit create, and it'll take you to this tab, and it looks a little bit weird, but first thing is you go on sources. So this is where we're going to import our files, right? So you go click on source files, and you just click on the files you want to do. If you hit open, it will try to import them. Here, this box is like your check to make sure everything's correct. So in case you forgot to change the thickness, right, here would read the 0.12 thing, but we changed it correctly. So it says 0.25 inches, aluminum 6061. Hit yes. And then it opens this thing. You can expand it if you want to like look at it a little bit more. You hit OK. Oh, what happened? Okay, inventor just lagged out a little bit. Yeah, so we have it here. So you can see that's what the flat pattern is like. It's just like a 2D face of whatever you're working with. So next thing we do is create nest study. And so here we can change our parameters. So you can change like the name if you want to. Let's see. Here you can select if you want, if you like unselect something. Here are their dimensions, right? And then packaging. So this is where you do the, like how big your stock is. And I believe you have to like edit the packaging elsewhere, right? So for now it's 39 by 19 and that looks okay. All right, we'll just go with it. And then global parameters, that also looks okay. So we'll hit okay and it'll do some loading and it creates that. There's our nesting. You can edit the nest. So if you click on nest here, you can edit it. And I believe this is where you change quantity. Yeah, it's been a while. That's why I'm saying I believe, but I'm not super sure. All right, so here you change quantity. So I'll just make this like 3, for example. We can make this 2, right? And then you can do other things like you can rotate it, you can mirror it if you wanted to. Right, but we don't need to do that. So we'll hit OK. And then it'll automatically update. And there we go. So that's what it's doing. You see that? Right, we have 3 of these, you have 2 of those. And I'm trying to find where the distance thing is, like the minimum distance. So where did it go? Oh, there it is, right. So item separation. Item separation is basically that minimum distance that should be between 2 parts. And so if I was using, so a 6mm end mill, which we, 6mm end mill that we generally use, right? It's like 0.23. So it's basically like 0.25. And so if I was doing this, I just do 0.55. Where did I get that 0.55 from? It's 0.25 plus 0.25, 0.25, that's 0.5, and then plus 0.05. It's 0.05, not 0.005. I think I misspoke last time.
Wait, where'd you get the 0.25 from again?
Oh, so that's the diameter of your end mill, right? So if we're using 6mm, it's like 0.23 something. So that's close enough to 0.25. So I just use 0.25. Do you guys see notifications by any chance? Oh, okay. All right, don't worry about it. Okay, so yeah, so I just do 0.55 here. And then this is like maximum runtime and stuff. This is basically if it takes too long to do it, you can like limit the time it takes, but we don't need to do that. Hit okay. And it should recalculate. And now the separation is bigger. Like you can see that distance between them is bigger, right? So there's our part. Let me see if I can find the packaging thing, like the size. Oh, there it is, I think. Extract or not. Oh, okay, I believe I did do this in my video. So that's always there. I think I need to rewatch my own video to do nesting. That's fun. But anyway, once you get to this step, right, you get the point. You have this, you click on the sheet portion here, and you do create 3D model. Right, so this is what's going to create a 3D model. Now here it gives you multiple options. So we don't want to do an assembly. You can just do a multi-body part file. The difference there is it'll create an assembly where each of your plates is a part, or it'll create one IPT file where each of your different pieces are a body, basically. Doesn't really make much of a difference, but we just do multi-body part file. And then you don't want to include stock. If you do include stock, it'll basically create like this huge rectangle and you're supposed to cut your pieces out within it, but we don't need that. So we'll hit OK, and we'll do some magic, and it will create a new part. There we go. Okay. All right, there it is. So you see this is our new part, and it laid out all our files, and this is 3D, right? And if you didn't set your thicknesses correctly, this is where it would be like super thin or something. But you have your new part here. and this has all your gearboxes and things, right? And that didn't take me that much time, right? Whereas if I were to do this in assembly, I have to figure out, oh, what's the best orientation for me to do all of this in. So once you get to this step, make sure you save, because you need to save the file, and we'll just call it nested plates, something, right? You have this, and now this is where you can begin the CAM process. What we did last week, or not last week, 3 days ago, whenever it was, we're gonna do the same process here. So far, any questions on nesting?
So you had like that layout thingy where like it had like gave like a little box or something around it. Yeah.
Yes.
How does it know? Is that like a random value or is it based on like the CNC that we?
Oh, so these values here?
Yeah.
Yeah, so that's the packaging thing I was talking about. So you can set these values to whatever you want. I currently do not remember how you edit that value. I know I figured it out during the season at some point, and I did that in my video, but I currently do not remember. And I just arrived at like where I am right now, so I didn't have time to tinker around. So sorry for that. I can try and look around, but I think, let's see. Let's try something.
What's he asking for again?
Huh? Packaging, like editing the packaging. That's what I'm looking. So this number is what I want to edit. Let's see. Can I create a new packaging or something? Nope. Okay. Yeah, so it has to do with the packaging. You find the packaging, you edit that, so you create a new packaging basically. Packaging is just like where everything should go. That's your bounding sort of thing. Yeah, I'm having a hard time remembering where it was, because I have not done this since like fill season. If any of you guys are on like Inventor, you want to try to look around, that would also work. Okay, we'll skip it for now. If I figure it out, if he's end like before time, I can try and figure it out and do it. But what I'll do here is we'll redo CAM.
For that thing under options, it had dimensions as well. Did you click on that?
Where
the
was
option
that?
thing that you're on, to the right. Like
Here?
the options.
Oh, options, that thing.
Yeah. It said dimensions.
Dimensions. No, I think this has to do with like what it shows you. So like, you know, all this green stuff it shows you, so you can like uncheck some of the things if you don't want to see it. Let's see. Okay, yeah, I'll skip it for now. It's like not a huge deal for nesting. Like there's more important things right now. You guys have to learn like camming, which is far more important than nesting. So we'll revisit it, right? I'll make sure to like send out a message saying how to do it. So don't worry, I won't leave you guys without tools. But okay, so what I'll do now is I'll transition into CAM. So if you were here last week, how about you guys guide me through what I should do? So I am on CAM tab. What should I do first?
Setup.
Setup. Do I click on it or what do I do? I have to be more descriptive, man.
Click it.
Click it. All right. Now what do I do?
Click the model. So hit the model arrow.
Click the model arrow.
And then click what you want to select. I think click all of them.
Yep. Click all of them. Sounds good.
And then hit the yellow box and then remove all stock.
Remove all stock. All right. No additional stock. Yeah. All right. Let's have a different voice. Arnav.
Now we have to set like where the origin is. So
okay.
You have to go to the like scroll down basically.
Scroll down.
There's nothing here. Sorry. Maybe third tab. That's
the third tab.
No, it isn't. Is it the second tab? Wait, were you on the first tab or the second tab just now?
I was on the first tab, sir.
Okay. It's the stock point. So you have to change the model orientation, or is it the stock? Yeah,
okay.
The model orientation.
There we go.
Choose one or the other.
Okay, and then choose one of these. And then what do I choose?
The z-axis should be up and down. So you choose like the height of one of the plates, like the height.
Oh, okay. I mean, the z-axis is already good to go, so I don't need to change it.
Yeah, okay. And the y-axis would be the longer side.
Yeah. So these gearbox plates are, oh, we can actually do an x-axis. That's better. There we go. So that, yeah.
Just, I don't think Jonathan brought this up the last time because he used a line, but you can also click on faces for axes.
Yeah. And so when I did that, like it messed up the Z. So I need to.
Wait,
All right.
isn't that mean your origin point is on the center? Like when you had it, that little contraption.
Oh yeah, I have to change the stock point as well. So
Okay.
which corner should I do? Oh wait, this is based on like the actual CNC, but generally when you're doing like plates, we do the top right because that's how the Laguna and that's how the Omi are set up. So
Don't you do any of the four corners?
yeah, you can technically do any of them as long as they are in the right direction. So
Okay.
like right now, if I were to cam this, right, you see how the X and Y are pointing out of where my plate is? My machine would basically try to go in reverse.
Yeah.
And that's not going to end up too well because I would start
So
cutting.
technically, if you would put it on like the bottom left corner,
Yeah.
wouldn't that work? You wouldn't have to flip anything.
Yeah, that would also work because then if I orbit 180 degrees, it's on the top right. So that
Okay.
also works. All right. So is our setup done or should I need to do anything else? You guys can speak. I just saw a thumbs up. I haven't heard a
It's
single
done.
word. Okay. All right. Great. All right. What's the next step? Should I do a contour?
Malvika, what do you think?
I don't remember, but I think the contour.
So I do the contour?
Um,
Are you positive?
no.
No. All right. So let's think about this, right? If I were to do a contour, so this yellow box is like the aluminum I have, right? And the contour would be the outer shapes, right? So if I were to cut out the outer shapes, what would happen to this whole middle piece here?
Like fly away.
Yes. So how do I prevent it from flying away? The answer is not super glue or flex tape.
Flex tape.
So what should I do first then?
I forgot what it's called, but like you have to do the inner parts, but I don't remember what it's called.
Yes. So the inner parts could be the pocketing or the holes, but yes, we have to drill holes first, basically. So now that you guys know we have to drill holes here, how do I drill holes? Someone other than Malavika, Jacob, and Arnav.
Bhavik.
I don't know, man. I joined late and I forgot this.
all right, that's fine.
Isn't there
Okay.
something like new operation or something? I forgot.
Oh, Mr. President remembers how to cam. Wow. All right.
And then you just like select the MBRT template. Yeah.
Yes, there we
The
go.
drill.
Which one from here? Which one from here?
Drill, aluminum drill.
Yes.
Oh,
Yes, that's correct.
And then
Okay,
you
so
choose the
right
screw
click.
holes.
Yeah, right click,
Yeah.
create from template, aluminum drill. And then we double click on it. And then it loads and you pick on the hole you want to do. So in this case, these are, I believe, 0.201, right? The tapped core 20s. So you see how it selected like all of those, right? But these ones are different sizes, so it didn't select them. Right, so what do I have to do here? I'm pointing to what is incorrect right now.
You have to like change like the size of like the whatever is drilling because
Yes,
Yeah,
I have to
the
change the tool. So you go in the leftmost tab, you click on tool, and then we said this was 201, right? So if you don't remember your hole size, you can still just press M or maybe that's not gonna work. Measure, right? And you get your diameter there. And then you double click again, pick on the hole, go in tool, change it to, and make sure you have the MRT tool library. So you change to the 0.201 drill right there, select, and now you see the two cylinders are like the same size, right? So there's that. And remember from last time, like these speeds here, these are the base speeds that we have like tested on our CNCs and they work and they're like safe. They're not crazy or anything. So these are like surefire speeds. You can go with them and it won't cause a problem. When you are doing it, like when you're actually machining in the season, sometimes you might be pressed for time and you might want to change these to make it a little bit faster or slower. Also, like if you have an end mill that's really dull, it's like weaker, right? So you can't cut at the same speed, so you might want to slow it down a little bit. But other than that, you generally don't need to change these values too much. And then these heights here, so I'm just doing this as a review, Cam. So like if you find it a little bit boring, it's because I'm reviewing. But the heights here basically define like the orange was like what's the safe height. This I don't know what color is like dark green. I don't know what the color is, but the retract height here is how far it goes up between like two holes that it drills. And then the blue one is like the bottom, like how far does it go when it drills. And you can see the blue is actually a little bit below our aluminum. And the reason for that is so that we make sure we cut through every single time, because our table isn't like super flat, and that it could have like differences from one side to the other. But yeah, there's that. And then this last tab is basically like, how does it drill? And there's all sorts of options. So like the first one that's called rapid is like, it just goes in and out, right? But the problem with that is when you do that, you're cutting a lot of aluminum at a single time, and that can cause the drill bit to heat up and other problems. So what we do is called chip breaking. It's like a woodpecker where it goes down a little bit and it comes back up, goes down a little bit more, comes back up, and so on and so forth. And the numbers here are basically like how far does it go down? How long does it stay there? Does it like just stay there a little bit, like pause and take a break or something? You do all that, you hit OK. There's our drill, right? And so I still need to do these two other hole sizes that are on this plate. So let's have a different voice tell me what I should do.
Like you can just like right click and like use the same template that you did for the other holes.
Mm-hmm. All right, I'm gonna do that. And then let's select this one. And so that one should be 0.196, but let's check. So I'll press escape and why is my measure tool not working? Anyway, measure 0.196. So we'll go back here, click that hole, and then we have to change the tool. So we'll go in here, MBRT library, change it to 0.196, select. Again, the speeds change based on like what tool you're using. And then same thing as before, right? All the same numbers and things like, or numbers are a little bit different, but it's the same things. You hit OK, right? And then the final one, aluminum drill, double click on that, and we'll pick the bigger hole this time. Change our tool to 0.257. That's the 1/4-20 clearance drill bit. And then none of you guys are confused about why these numbers are what they are, right? Like the 0.196, 0.257, right? That's because 0.196 is if you're using 10-32 screws, they can slide through. 0.257 is 1/4-20 screws can slide through. And then 0.201 is you want to tap the hole for 1/4-20s. The heights and the numbers there, okay. Right, so another thing that we actually didn't get to last time was we have these 3 different drill bits here. And so like, obviously this is kind of confusing because it just says drill 1 and like there's other numbers like T16, T14, T17 that signify which tool it is, but I don't remember those numbers. So what I generally like doing is renaming these. So you can just either right click rename or double click slowly and you can change the name to, so 201 drill, for example. Right, and you can make this, what was this, 196 drill. That way it's easier to identify it. And then if you like go back later and you want to change something, 257 drill. And generally what we like doing is when you're machining, going in ascending order of like tool size. So you'll start with the smallest hole, so the 196 one, and you can just drag it to change the order, and then the 201 and then the 257. The reason for that is when you're actually working there on the CNC, it's easier to go up in like an incremental order than go in a random order. And also just helps with like, because the smaller holes are easier to cut, right? So things vibrate less and you can put screws in and then everything's fine, right? So
I have a question.
Uh-huh.
So okay, don't you like export each like template individually when in like different files, essentially like G-code files?
Oh, the drills, yes.
Yeah, so couldn't you just rename it then?
Couldn't I rename them? Oh, okay. So what you're talking about is basically when we post-process, right? You can have a file name there. So that's different because post-processing is the file that runs on my machine, right? The CNC. And so yes, you have a name there. but this name is different because this name is inside my inventor. Um, it's like the equivalent of if you were to have a model that's called Gearbox 201 and you export it into Cura and you were like 3D printing it, right? The 3D printed thing has a different name and this has a different name. And the reason for writing a name here is so that if someone else opened this cam, or if I open this cam later, or if I'm just like going through again, right, I can identify what it is without having to double click or measure, right? It's two different things. The two files are separate. So that's why.
Also, if you put the USB into the Laguna, then what happens is that it shows each process and it takes whatever file name is given on there. So you can also use the name that you export it with. Well, that comes with the exporting name, but it takes whatever process you have default. I think it takes it default, right?
Oh,
Like if you were to post process a single like 196 drill. By the way, your camera's flickering.
yeah, give me 1 sec. I need to turn on the lights. Something happened.
But I'm pretty sure that if you were to export a single process, then it takes that name by it takes as a post processing files name by default. So like that's also good because I mean it doesn't really save much time, but you'd want it to be that so that way if you were to plug it into the Laguna, then you know what process it is, right? Because if you have all your files on that USB, it's hard to discern the difference between each file. So yeah.
That was an adventure. Okay. All right.
Where the hell is your light switch? That was like 20 minutes.
No. It something random happened. I don't know. Okay. So what should I do next? I'm done drilling all my holes, and if I was on the machine, I would put screws in them so that they don't fly away. What should I do next?
Oh, create more templates for like the pocketing.
The pocketing. Yes. Should I also do a drill for the bearing holes, or what should I do?
No, because we don't have a drill bit big enough.
Yes. Okay. We have a drill bit that's big enough, but it doesn't work on CNC. But yeah, same thing. So we'll do create from template.
Wouldn't it be better to like put a hole in the bearing and then do a contour so that it won't take that long during adaptive?
So, okay, so that's a good question. You could do a contour and put a hole in the middle, but the reason why we generally don't do it is because, so in terms of preparation, right, when you're camming, I would have to, let's see, how many bearing holes are here? 4, 6, 8, 10. There's 10 bearing holes. I would have to make 10 like drill points here, right? So that takes me time in terms of my cam process. And then I have to actually go on the CNC and do that. And you can't, so with those like pucks, we call them pucks, the things that like fly out, you can't use one hole. I know it's a circle, but still you have to use 2 points so that the thing doesn't like start rotating around that one place where you screwed it in. So you actually have to put 20 drillings here. And in real life, you would have to drill 20 more holes and then put in 20 more screws so your bearing like pucks don't fly out. So you do all of that work to save not that much time because a bearing hole is only 1 and some inches wide and adaptive doesn't take that much more time than contour. And so that's why for this, we wouldn't do it. Although if you had something like a swerve plate, which let me find one. Where could it be? Oh, give me 1 sec. Where is it? Huh, no, not that one. Where did it go? Okay. Let's see. Let me just find it from here. So if you had, right, so if you had like one of these plates, right, with this huge like 4-inch hole in the middle, now this adaptive would take forever. So this is where like doing the, like putting the screw holes in, this is where it's actually efficient because you spend a little bit of time in your cam, but it saves you so much time when you're actually machining, right? But for bearing holes, it's not that big a deal. And we actually did this for when we were machining the swerve for, what was it? Forget a team number, 604, yes. It's been a while. Okay, there's a chat. Could you go over what I mean by screw holes? Okay, screw holes is, so if I were to, let me do contour real quick. So if I were to do a contour for, let's say this, oh, not that, this bearing hole here. Let's simulate that with some stock. All right, so there it is. Okay, so when I do a contour, right, it creates this, what we call a puck. It's just this little piece of aluminum in the middle that's circular that like can fly off because it hasn't supported by anything because everything around it is cut. And so a screw hole would be, you basically drill a hole in this middle piece before you do the contour so that you can put a screw inside it and so that it doesn't fly off. So that's what a screw hole would be in terms of pocketing and preventing like getting away from doing the whole adaptive thing. Yeah, so that's that. So when you're drilling with the CNC, you use clamps. Oh, okay. Yeah, that's another good question. So when we do our drills, right, when we were drilling the first holes, we have our huge piece of aluminum on the table, and we basically have clamps that are around the edges of that aluminum to keep that from going anywhere. And then once you drill the holes, you can hold down the parts where you're cutting. So yeah, we do use clamps for the edges basically. Right, so let's delete that contour and let's do our adaptive. So create from template, adaptive, double click that. And then now we do the fun stuff, which is just selecting all the pockets. There's a 6mm end mill, so just select, select, select. Now another thing that like, so if you're camming this, you can select like every single pocket at once, right? But something that works for the Laguna is the Laguna's like thing you hold in your hand, like the handheld processor. It's not very good. It can't hold like a lot of data at once, and basically adaptive, because it does so many like circles, adaptive operation are like really big in terms of file size. And so generally on the Laguna, if you were doing adaptive for like 5 different plates, it might just stop on the 3rd plate and just like forget what it's doing basically. So generally what I do if I was working on a Laguna would be do adaptive for like 1 or 2 plates, like all of the pockets on 1 or 2 plates, and then you do a different operation basically, so that you split up the load between 2 files instead of just 1 huge file.
If you're using the Omeo, it doesn't matter.
Yeah, the Omeo doesn't matter because for the Omeo, the controller is the computer you have hooked up to the Omeo, and the computers like Mr. Shinta's computers are good enough. And then if you use your own computer, if you can run like Mach 3, it's fine. It works. I actually had that problem. My old computer couldn't run a whole operation on the Omeo.
Imagine. Also, if you, I guess this is just similar to any CAD, any other process in CAD. If you accidentally select something that you don't want to, just shift and click again, and that.
So like I'm gonna deliberately select this one, and then that's wrong. So I'm gonna press shift, and I can click on it again, and it goes away.
Yeah. So like just because it's very easy to mess up, as clearly Justin has messed up like 5 times so far. Yeah.
Don't mention that.
If you were to mess up, then shift click is the easiest way to. Yeah, you don't have to like stop. You don't have to like delete everything and then restart.
So if you were going to use like the Laguna, like right now, you would just only select those 2 first plates and then be
Hit
done,
okay.
and then create a new template.
Yeah, create a new adaptive operation. Yeah. So for the sake of time and like not boring you guys watching me click a whole bunch of pockets, I'm gonna pause here with 3 plates. So the height thing again is the same here. Now going into this tab, you have a couple of options. So the first thing is stock to leave, right? So this is an option that basically allows you to undercut or overcut even. What it means is, right, so if I have a bearing hole that's 1.125 inches, I can add a number here so that I only cut 1.1 inches or 1 inch or 0.75. And why would you want to do that? So basically when your end mill is going around cutting all of this aluminum out, right, it's doing a lot of work and it's fairly stressed out. And so the quality it leaves behind on the aluminum itself isn't always the best, right? Because it's doing so much work. And so if you want your final product to have really good quality, but also not take forever by going super slowly, what you can do is you can leave a little bit of stock. So you cut 1 inch super fast, right? And it looks really bad. But then the last 0.125 inches, you do really slowly so that you leave a really nice finish at the end, right? Because the end part is what matters. The middle portion we don't care about because it's just flying into chips. So that's what we do is what you can do is you can leave a little bit of stock, radial stock to leave 0.005, and then you can come in again and cut away that 0.005 so that you have a really nice quality finish. Now, for the pocketing, like not the bearing holes, the pocketing, it doesn't matter because like you might care about the finish, but it doesn't actually matter if it's too small or too big because it's 0.005 inches and we don't actually use pocketing, right? So you can choose to leave it on or not. I think last time I didn't leave it on, so this time I'll leave it on. Hit OK. And then now it's going to do the calculation, so it's going to take a little bit of time. And hopefully my computer doesn't crash. Oh, it's loading. It's trying to load. It's almost done. It's almost done. There we go. It's done. Yay. Okay. So that's what it looks like. And the yellow spider web of lines. So I guess I could just cover the colors real quick if you're confused. So the red is like it's starting something. So it's like, you see how it's like a coil? It basically starts at the top of the aluminum and like helixes down into the aluminum. And the reason why it does that is so they can create like a cavity for itself so it doesn't get stuck. The blue is like the whole cutting portion. The yellow is basically when it's not actually cutting anything, it's just moving to the next place, right? So the yellow between like two different holes is it's moving out of this pocket, going to that pocket. And then if this is your first time doing CAM or like you haven't actually machined anything, you can hit simulate and you can like see how it actually does it. So I'm going to slow that down and hit play. And so it's going to come down. It's going to do the helix thing. Actually speed it up a little bit. Does the helix thing. And once it's all the way through, it starts going around and around and doing the shape that you want it to do. So in this case, I think it's a bearing hole. Yeah, so it's just going around and around and around. Then it'll move over to the next part, right? And then we'll look at it from the bottom this time. So it's doing that. And then it does movements around wherever it was doing the helix so that I can cut out the final shape. And you can speed it up and see it's doing that, and it moves over to here. Now, this is something that for some reason Inventor Cam does that like I haven't been able to figure out. Andy, who was here before us, he was also like, he hated this feature too. But when it does adaptive, why is my adaptive not loading? Oh, there it is. Okay, so when it does adaptive, it like, so it would do this hole first and do like another hole there, and it moves over to the next plate, does those holes there, and then it comes back and does this one, and then that one. It like moves across horizontally instead of like doing all the holes in this area and then moving to the next one. So it does that, which I think it like takes a little bit more time because it has to do all these movements. It's not a big deal, but if you want it for it to be like more logical almost or more intuitive where it does all these holes first and then goes to the next one, you can just do different operations. It's not a big deal, but yeah, that's something that's like a quirk of Inventor Cam.
Wait, so on like when you're actually CNCing it,
Uh-huh.
it won't do that, or
No, it will do this. It will do basically whatever it shows here, where it will do these like 2 holes or 3 holes, and it'll move over to the next one and do those. But it's not a big deal. Like it's not gonna take an extra hour because of it. Only thing is like sometimes I want to do one plate first, check what it's like, and then move over to the next one. If it's like failing, I can like change my cam. So in that case, what you could do is do another adaptive, right? And then you just select the entire plate. You do that first plate, and then if it looks good, you can go over to your next plate. So that's one way to like check what you're doing, make sure everything works. If there's anything wrong, I can go back and change it. Yeah, so remember that we did stock to leave. So that means this is actually going to be 1.12, not 1.125. So what we're going to do is use this last template called finishing contour. And the difference between final and finishing is final is the final shape. Finishing is like adding that finishing touch to it. So that's how you can remember it. If you have a better name suggestion for like, so that does not as confusing, please let me know. I can change that. And so now I'm just gonna select the bearing holes because the pockets again don't matter. So we're gonna select the bearing holes. Nope, not that. That one.
So the finishing contour is only usually used for like big holes or something.
Finishing contour is for when you have that like last 0.005 left and you just want to cut that out.
So why didn't you do it for like your other parts, not just the bearing holes?
Oh, you mean like the other pockets?
Yeah.
So the reason why I didn't do it is because the size of these pockets doesn't really matter, right? Because they're only there for saving me weight. And if there's 0.005 inches of aluminum that's extra, it like doesn't really matter because there's no screw going in there, there's no bearing going in there. So that exact size is not important. That's why. Because again, if I could select these and I would get a really nice finish and it would be the right size according to my CAD. But the problem is it'll take you like an extra 20 minutes, 30 minutes, depending on how much you're doing. So time oftentimes with machining is more important than like having it the perfect size for a random pocket. And you could probably do these ones as well because this is where the motor pinion goes. So if it's too small, your motor would get stuck. So do those. And so you might think like, what's the difference between this contour and the other contour we do to cut out the final shape? The difference is actually in the speeds here. And the reason for that is, and also like in the other tabs, is basically when you're doing the final shape, you have to cut out all of that aluminum around the plate, right? Versus when you're doing this finishing thing, remember we already cut out a hole here. All we're doing is cutting away that last 0.005 inches so that we have a really nice finish. So over here, my end mill has far less stress than when it's actually cutting out that final shape. And so that's why the numbers here can be faster. I can get away with like not having a ramp down. I can just go straight in, cut that last 0.005 inches out. So this is why there are two different contours. They're not the exact same thing. And you can do like the final one on this, it would just be slower, but you can't do this on the final shape because it would be way too fast and you would kill your end mill. And also Mr. Shinto will yell at you for being bad. Hit okay. And so it just comes down one time and does that one pass basically. That's another difference. It only does one pass. It cuts 1/4 inches of aluminum at one time instead of doing like super small bits. So, and then I have all this adaptive and contour here. So again, I generally like to change the name to like 6mm adaptive. And let's make this 6mm finishing. Right, so what's the final step if I want to cut these first 3 plates out? Anyone
Like,
other? Contour? Yes,
it's
final
like
contour. Yeah. So we'll do final contour. It's already set
just
to.
call it contour.
Huh?
Instead of calling it final, couldn't you just call it contour?
You can call it contour, but the other one's also contour, like the one where you do finishing on a bearing hole.
Oh,
So
okay.
yeah, you can call it either. It's up to you, but I just want to have it separate so that you don't get confused because they're both contours, but there's a difference between the two. So we'll select the outer edges here. Let's do that. And then again, the speeds here are set based on the machines. Other differences. So this is one place where the two contours differ is when we do multiple depths here, that's basically saying we don't want to cut all 1/4 inches of the aluminum at a time. We want to cut a little bit at a time. And so we're going to only cut 0.04 inches. Where do we get that number from? Well, we just tested like what number works where it's not cutting too much, but it's also going at a reasonable speed. Say you just do 0.04 inches at a time and you keep doing until you get to the bottom. And then this last bit here has a ramp. So we ramp into the aluminum instead of just going straight in. Reason for that, again, it's smoother and it doesn't hurt the mill as much. Hit okay. And it will generate, and you can see that multiple depth option here because you have multiple blue lines. So it's going to go around multiple times. And what it looks like when you do a simulate is it comes around. You see it only cut a little bit at a time, right? So it's going to come around again. It should. There it is. Okay. It's going to come around. It's going to cut a little bit more. You can speed it up. comes around, cuts a little bit more, a little bit more, a little bit more, even more, a little bit more, and there it is. It's fully done cutting everything. Now we'll go on to the next plate, right? And this is where you can see our nesting working. So you see how these two plates are separate. Actually, I'll speed up a little bit more. And there was this gap in the middle. So we did like the 0.55 thing, right? I'll just wait for it to finish. Right, so you see this here? This is that minimum distance, right? And you can see there's that little bit of aluminum left. What would happen if we didn't set this? So you could have a situation where the two parts are way too close and like your end mill basically cuts away part of the other part. A second situation is you don't have this middle web, like, or this thin piece in there. And basically this piece here would be alone and it could just fly off, right? So that's something else that's dangerous. We want to avoid it. And so that's where the nesting thing helps. And yeah, it just does that. Right, and so that is all of our cam done. Now, anyone remember how do we post-process? Different voice than Arnav, Jacob, Jasmita, were you there last time? Okay, then give it a try. You have to unmute first. What is this?
I don't know off the top of my head.
Oh, you don't know
Like-
top of it? Okay. Do you remember like what this step does? Okay, so it's like compiling. If you take coding classes, right? So we define that we're gonna drill this hole and we're gonna drill it this way and all that, right? So the machine doesn't understand that because it's way too high level for it. So you have to convert to what's called G code. It's like binary for a computer, but it's G code for a machining thing. And so you click on what you want to do, hit post process, and this tab opens up, right? So there's a couple things here. So the first thing here, this is kind of like what compiler you're using. It's how is it going to convert everything? So this depends on like whatever machine you use. You see there's all these options here. We use the Laguna. So we have to select the Laguna. This won't be there by default. Like Inventor has some of these posts already there, but it won't be there by default. So what you have to do is you have to go into files. You have to find your parts library, where it is, GrabCAD, parts library, CNC, post processors, and there's three. So there's Laguna for the Laguna CNC, there's CNC router parts for the Omeo, and then there's Glowforge for our laser cutter. But I haven't used the laser cutter, and so I can't help you much there. You have to ask Shinta for that. But yeah, you take the Laguna file or the Omeo one, or both, and you Control C, and then you go to this piece. You go to your C drive, users, public documents, Autodesk, Inventor, CAM, posts, and there's all the .cps files. There is chat. Why is the Omeo one not called the Omeo? Okay, so the reason why the Omeo post processor is not called Omeo is because if I remember correctly, it did not come with its own, and there's like third-party ones, or it came with its own, but the third-party one is better. It's one of the two. But basically, this is like not made, or I'm pretty sure it's not made by the company that makes the Omeo, but it's like it works well. So that's why we use that. So yeah, that's how you do that. And so once you do that, it should show up here. So Laguna CNC shows up. And make sure whenever you start Inventor for the first time, like you click on Inventor, it starts, it will always be document unit. You want to change this to millimeters because both of our machines run in millimeters. If you don't change it, your part's going to be like this small because it's cutting 4 millimeters instead of 4 inches. There is another chat. Could you show what you do if you were to use the Omeo? Oh, okay. Yeah, so I actually don't have the Omeo one in here, so I'll have to go through that step again. So documents, GrabCAD, parts library, CNC, post processors, CNC router parts, Control C that. And then we go back to OS, users, public documents, Autodesk, Inventor CAM, posts, and we paste that there. And then now in Inventor, if we scroll up, CNC router part should be there. I think I have to cancel and have to reload it. So click that, post process. There we go. I think it works now. there it is, CNC router parts, that one. And you do the same thing, millimeters, post, and then here. So this is where what I would like to do is create a new folder for whatever I'm cutting. So like, let's say this was WCD gearbox 1, right? Or comp plot or something, right? You give it a name, a folder, and then inside there, you post all your operations. Now, this is where we kind of have a naming convention. It's like our own thing. It's not like fully standard, but this is actually a useful naming convention. I'm not saying the CAD one isn't useful, but it's definitely not as useful, right? So what we do here is the first thing is a letter, and that's like the order in which you're going to cut everything. So this would be A, because it's the first thing we're doing. And then you do the size of your tool. Now, the reason for that is if I were to cut this and you were the one who cammed it, instead of you telling me I'm using these 5 tools, I can just look at this name and see what tool I need to use. So I would just do 196, drill, and then save that. And the reason why this is useful is if I were machining and all I had was that USB, I would put this in the controller. I would see it's A, so I have to do this first. I have to use the 196 drill, and it's good to go. So you do that, and then you would do the same thing for 201, right? So everything's there. You just change this to go to the right folder, and then we'll change this to B, 201 drill, right? I won't bore you with the other one. And now the adaptive and the contour and the finishing one as well, they're all done with the same end mill, right? So I could post-process them, all of them together. So what you do is you select all 3 at once. Sorry. So you would click the first one, press shift, and then select all of them, post-process, post, and you just do, where did it go? So you could do like C, 6mm contour or whatever you want there. And that would be good to go. And then you could take this folder that's there, put it on the USB, and you can machine it yourself, give it to someone else, and they should be able to do it.
You were saying something how like it doesn't get accurate towards like the end or something. Is like, what would you do if you were when you were post processing that? Like you were saying how it gets overwhelmed with like so many stuff to do.
Oh, that, yes. Okay, so if this were on the Laguna, right? If I did all these 3 at once, there is a high chance, because this is such a large file, right? It has to do all these different steps, that it would like forget or it would just stop in the middle. It's happened a lot, unfortunately. So the way you would avoid that is instead of selecting all 3 at once, you would just select this one, post-process it, and then maybe select these 2, because contours are pretty easy, so they're fine. But the adaptive ones is where it starts to cry. But yeah, that is day 2 of CAM. Yeah, you guys have any other questions?
I have a question. Like
Mhm.
under your list of operations, like what is the 6mm finishing? What does that do again?
What does this do again? So remember, in our adaptive, where was it here, right? We did stock to leave. What basically this does is it takes everything, the size of everything, and it cuts it 0.005 inches less. So this bearing hole is 1.125 inches in diameter. It cuts it to 1.12. And the reason why we do that is so that we can cut that adaptive super fast and go super aggressive, so that the final finish is like, it's bad because it's going super fast, trying to cut all this stuff at once. But then this finishing comes in and it cuts that last 0.005 inches that's there to basically put like the icing on the cake. It like does this really slow and nice finishing pass so that everything looks really good.
Okay.
But that's the point.
And then, and the last one, like the 2D contour one, that just cuts out the outside, right?
Yeah, it just cuts out the outside final shape that's there.
Okay. All right, thanks.
Any other preguntas?
For the adaptive and finishing like the stock to leave,
Mhm.
if you change the amount that you have in adaptive, do you have to change something in finishing?
No, you don't have to change anything in finishing. So if your adaptive is there, it'll just cut whatever that's there, and then finishing would just come in and change like whatever is there. The only problem would be if you change, let's say 0.01, right? That's like twice the amount. These settings here are for that 0.005 inches, like the speeds and everything. So if you were to make it bigger, I would, you could try it at first. And if it seems too aggressive, you probably want to cut it down a little bit. So that's the only thing you would potentially have to change if you do change it. But 0.005 inches, like so far, whenever we've done it, it works. So you probably won't need to change it. If you do, you just need to change the speeds a little bit probably.
Oh, well, what I was asking is like,
Mhm.
if you were to change it, do you have to change something like in terms of how much it cuts in finishing?
Oh,
or
no,
does
no,
it
no. So
do that?
the contour,
Okay.
it basically uses your CAD file, and whatever your CAD file says, it'll just cut to that size.
Okay, I see.
Yeah, yeah. You guys have any other questions? Ritvik, so are we gonna do a day 3 of CAM, or what's the plan?
Looking at it, all they need to do is
2x1s.
give them, yeah, all they need to do is 2x1s, and I mean, we can give them an assignment, right? So,
Yeah, I think.
assignment.
Huh?
Assignment.
Yeah. Yeah. Assignment, like you guys can just practice on your own. Just find a CAD file, just cam it, nest it.
I guess, yeah, we can have a third one.
Yeah. Yeah, so we'll need to do, we can do a final day of doing 2x1s. 2x1s are like the exact same thing almost. It's just the setup is a little bit different, but everything else stays the same. 2x1s are actually less work in terms of CAM. Like this is probably the most work you have to do in terms of CAM. So nothing.
The more like the challenges that come with the 2x1 are more on the actual CNC. So you guys are lucky about that, because there's some other specific things you need to learn with the machine. So yeah.
If you guys do not have any questions, I think you are free to leave.
This is probably